So what we wanted to find was the for each size of order, how many orders of that same size. So we'll get to something like this. So orders that has 6 items, there's 17,742 orders that has 6 items in them, and so on. So here I'm starting with the just loading the files. Now, the first step is I have here the order. This is something we've done before. We've got the group by the order ID from the order products, the data frame, and we collected the list for the product ID. Okay, why am I getting an error? Connection refused. Let's restart. I think that's happening because I have the same application name, maybe. I'm not sure actually, because I did not change the application name from the previous notebook. Okay, so here we are grouping by the order ID from the orders and product table, like the data frame. And instead of like getting the maximum or the average or something, what we're doing is that we're collecting all the product IDs. So any product that falls within the same order ID, that's the one group we're getting, we're collecting all of them. And we're giving this new column an alias name of items. And this is it. So for every unique order we have, that's the list of items or products that are in it. And we can find, like we can select from this, the order ID and the size of the column items, which would give us the size of every array inside this column, basically. And we will get something like this. Now, what we can do is like simply, we can group by the size, because that's what we want to have. Like for every unique size of an order, like the number of products inside the order, we want to find out how many orders exist. So for all the orders that have 14 products, how many orders are those, and so on. So what we can do is that we can group by the size. Now, I could have got to this point in a different way. I didn't need to have collecting the list and then getting the size. I could have just counted, like in this group by the order ID, I could have just counted how many products we have. And actually, it would have been more efficient. I kept this because that's what we started with from last notebook. But if we don't actually want the list of items, we don't need to collect them and then get the size. We can just count here instead of doing all of this. And it will count every group of order, like every single order, it will count all the products in it and give us the value immediately. So at this point, I have this, and I can group by the size, this column here, size of items. I did not give it an alias name, but we could have. And we're counting. So what we end up with is for every number of products per order, or every number, like quantity of products in an order, this is how many orders exist in it. So if an order that has 31 products, there's 721 orders. You can see you can notice as the number increases, there's less orders, which makes sense. Like having 53 products in one order is not as common as having 1 item or 6 items or 3 items and so on. So now we would like to plot this data. So Spark doesn't have a plotting API that we can use. However, once you get to a point where you want to plot the data, you're not dealing with big data anymore that cannot fit on your machine and cannot be handled on your RAM, basically, or your just one machine. In fact, if you do everything on the cluster that you're handling with Spark, if you don't need to, then you are wasting resources. So usually once you finish the analysis and you reduced the data to a small number that is like feasible to be loaded to your RAM, you collect it, and you can sometimes even continue the analysis without having the Spark part. So in Python, there's a really powerful library called Pandas, and Pandas provide data frames. And this is like the maybe traditional way of doing data analysis in Python. Spark is for the big data, the MapReduce architecture. But if you're just doing data analysis, chances are you should be using like Pandas in Python, if Python is the language you're using. So we can easily convert, and Pandas have a nice mapping of the API between the matplot library, which is a popular library for plotting, as part of the data frame itself. So first, we can easily convert our Spark data frame into a Pandas data frame. So in fact, like this is the data frame we have. And if you do .2 and you see what we can convert to, there's a couple of things we can convert to, or a few things, like a JSON object would be one of it. If we get this as a JSON object, it's going to collect all the data, and it's going to return a JSON object with the data, which I think it's okay. It's probably returned an RDD of a JSON object. Yeah, so it returned an RDD, which inside every element like a JSON object. But if we do to there's Pandas, this is going to convert. It will collect the data from our Spark data frame, and it will load it into a Pandas data frame. So the return from here now is a Pandas data frame. This is how the Pandas data frame is displayed in the Jupyter notebook, and it follows very similar concepts. So it has columns, and one thing different that it has an index, which doesn't have a name specifically, but it's an index. We can choose to have like one of the columns as the index, but we can keep the default, which is just like 0, 1 until the number of end of the data. Now we can, yeah, and here I'm starting with this data frame, the Spark data frame, and I'm removing all the columns that, all the counts that are less than 100 orders. So I'm filtering out some data, like cleaning it up. Instead of having like 65 with count 4 and stuff, I'm just keeping those that have at least 100 orders, which I think is reasonable out of the numbers we have. Like at 3 we had 15,845. So the ones at like under 100, we can remove them, but it's up to you. Like, it depends on what you're trying to achieve and what is the purpose behind what you're trying to visualize or the analysis. But that's what I'm doing here. I'm filtering out all the orders, or actually all the sizes that had less than 100 orders of them. And then I'm selecting the size, like just the same columns as I have. I'm just giving it an alias name of size. And if we look at it, that's what we get. It's just the same data. We're filtering out the ones that have under 100 orders, and changing the name of size items to size, and keeping the column count. So we have the size of the order and how many orders there is for this size. Now, if we convert to Pandas, we're going to get a Pandas data frame. So this is the df count per size Pandas as a Pandas data frame. At this point, we will be out of the Spark environment. We will have collected the data from Spark, and now it is loaded into our just machine, our RAM, our Python environment. Connection refused. Probably this is happening because I have many notebooks open. So let's restart. Also going to remove this 4 here. Technically, we should, when we are done, to close the session after it opened, which we are not. Or you can like make sure you're terminating the notebook that you have open. Like in this, for example, this is still open. Spark's like the 6th notebook, and like I might have others still open. I don't know. So both of these are running. Even if you close the tab, they will still be running. But anyway. So once we get to here, now our data frame is no longer a Spark data frame, it's just a Pandas data frame, and we can use the Pandas API on it. And there is a function on the Pandas API, on the Pandas data frame that we can use, which is plot. So this is the Pandas data frame after filtering the count to 100, like less than 100. And what did we do? We changed the name of size here, like size items to size. We get this data frame. It's a Pandas data frame. And on the Pandas data frame, we can use the plot function. And the plot function takes multiple, like, if I just do plot, it's going to give me this, which is basically it's going to take every column as the data I'm plotting, and the x-axis is the index. So this is the x-axis, and this is plotting 2 separate lines for each column. But that's not what I want. What I want is to have for the x-axis, so I can specify which column it is, it's the size, and for the y-axis, I want the count. And if I do this, I'm going to get something like this, which is messy, but not for the reasons you think it is. Like, it's not because it's a line. So let's first change this plot to a bar plot. So I can change the kind of the plot to bar. If you look at the documentation for pandas data frame.plot, you can see we can pass multiple things. So we pass the X, the Y, the kind, there's multiple kinds of plots. At the core, it's basically using matplot library. So we can get the, or pass a specific access like matplot library access. If you've created something before that you can pass it here, so it will use it. That's a bit more like advanced into matplot library. We can define if it has like subplots or not. By default, it's not. So it can create, like if you have multiple columns, let's see that in action. Before we've added this, all of this. So at this point, for every column, it was having a plot, a separate line. So let's say it's true. Now it created subplots automatically for every column you have, which is cool if you actually have separate columns and you have the index to be the one of the x-axis. This is really easy to plot subplots. But that's not what we're looking for, obviously. There are other stuff, like sharing the x-axis for the subplots. In case the subplot is true, it will share the x-axis. So if you want to see it in action, we can, because we're doing the okay, we get an error. Line 2D object has no property.
It's just share X, I think, without the bool. You copied the bool too.
Oh, okay. Yeah, makes sense. Actually, by default, it was true. So this is what we're getting by default. So you can see that the x-axis is this shared here. It's not redefining it. So if we set this to false, now it has a separate x-axis for each one. So there's other things, like there's the title of the plot. So let's go back to our plot here. We specified the x, we specified the y. We can specify the title. This is the size of, actually, number of orders, their size of order. That's what we're plotting here. And now it will have it as the size, as the title here of the plot, for example. Now, what do you think is wrong with our plot? Like, do you find it good?
The x axis is really messy and unordered.
Okay, so we're starting like 31, 34, and so on, which is actually the data we have. Like, this is the data, 31, 34, 28, and so on. So we can sort the x-axis to have a better plot, basically. And we can do it inside the Spark, which you can order by and like then collect again. But at this point, we've already collected the data. It would be a waste of like resources to go back to Spark and collect the data again. So we can just sort them inside the pandas. So here in with this pandas data frame, I can do sort. We can sort index or sort values. In this case, we want to sort the values. These are the values. So we specify which column we want to sort with. So we want to sort by the size. If I run this, it's going to give us a new data frame, which data frame is like similar to Spark. Every time you run something, it's going to return a new data frame. And now it is sorting the size. So now if I plot again, on this new data frame after the sort, now our data looks like reasonable. It's actually a nice plot that we can see that as one would expect, as the number of orders, like the size of the order increases, the number of orders would decrease because it's not very common. And we can see that there is like a curve kind of shape, because this is the like between 5 to 6, 7 like items would be the average order that the person would have. Now, if I go back to the line plot now that we tried, now it makes sense. Before it didn't make sense because the order of x's was wrong. So it was actually plotting them in the, so once I had this, it was still plotting the lines correctly, but the order is wrong. So it's moving from this point to a point at here for the x, then a point at here, and so on. That's why we're getting this shape. But once you sort that values, we can still get a line plot that is nice, which represents the curve. Or we can have the, you can use a bar plot, which would look something like this. Now, what this returns is a, you can see it's called an object of access subplot, which is coming from the matplot library, So if I save this as a plot here, I can access things on the like from the matplot library. We can keep the name PLT, but the suggestion, okay, it doesn't matter. So we can, like, for example, get X labels, I think. Nope. Let's go to the matplot library. Okay, X label, I think, without the S. Okay, so the label at X is size. So we got the size, for example. Now we can even set the X label if we want to change this label. Now it's changed. So we can call things on this plot based on the Matplotlib library API that you can use, or like there's a lot of things that you can do. It can like really go advanced. So it's up to you to explore as much as you want. But if you might want to be able to change the X ticks, that's what the ticks of this X-axis. So sometimes if you're dealing like Monday, Tuesday, Wednesday, you don't want to see 0, 1, 2, 3. You want to maybe change them. So there is something about these ticks. Get X ticks, for example. If I do this, these are the ticks that we are getting, that are being used here. You can notice that there's a 0 here, because these are the ticks, but not the labels of the ticks. If we do there should be ticks labels. Yeah, X ticks labels. So if we get the labels of the ticks, these are the labels. Each element inside of it has a value from minimum to maximum and the actual label. So if you want to set the labels, you can set like, you can use the set function for it, and you can pass an array, but this has to match the size of this. So in here we have from 1 to 43. So 43 elements. This has to match this. Let me try to. Let's say 54. I'm not sure if this is good. Okay, so I just changed the labels. I don't know if you notice what I did here, but I basically created an array consisting of a string of an X that starts at 10 and ends at 53. So it's like a for loop in place that will return an X starting at 10, ending at 53. For each element, it's putting the string of this X inside the array. And then this array is passed to this function, which is used, like it's generating these basically from by setting them. And in the plot, you can see I have now 10, 11, 12 until 52. This doesn't make sense, but I was just like showing you how you can use the X tick labels. So now for the exercise, I want you to, with your group, like choose a few things that you want to collect from the like data that you want to retrieve from the, or some analysis that you want to retrieve from the data, and I want you to visualize it and like have fun, like try to find something, even if you can find something that you can have like multiple plots in the same thing, like one index, but multiple columns that can be plotted. That would be fun to see. Any questions?